Hello students, welcome to class PM. In today's class we are going to discuss about the first type of chemical bond, that is ionic bond. So based on the Kussel and the Lewis approach, that is octet rule, now we are going to learn what is ionic bond, how this bond is formed between the two different atoms. Generally the ionic bond is formed between metals and the non-metals. We know that metals have the tendency of electropositivity, which is losing of electrons, and non-metal have the property of electronegativity, which is gaining of electrons. So generally the ionic bond is formed between metals and the non-metals. How this bond is formed between metals and the non-metals? So this bond is formed between metal and non-metal by transferring of one or more electrons from one atom to another atom. Okay, how it will be formed? By transferring of one or more electrons from one atom to another atom. Generally, metals have tendency to lose the electron. That's why electrons are transferred from the metals to non-metals. And so metals lose the electrons and they become cation, and non-metals gains the electron, they become anion. Anion means negatively charged and the cation means positively charged. So metals are forming positively charged cations and then non-metals are forming negatively charged ions, so that two oppositely charged ions are formed. These two oppositely charged ions, what they will do? They will combine together by electrostatic force. We know that whenever there is a charges of opposite, okay, they will come together by the electrostatic force. Now this electrostatic force, they will combine the cations and anions, so that the bond between these two oppositely charged ions is called ionic bond. So that this is the way you can define the ionic bond. Ionic bond is a electrostatic force which holds the oppositely charged ion. Ionic bond is a electrostatic force which holds oppositely charged ions. This is the way you can define the ionic bond. Let's see some example. Therefore, let's take the examples of some metals like sodium, magnesium and aluminum. So sodium electronic configuration is 281. So there is a one electron in the outermost shell. That so if this sodium will lose this extra one electron from the outermost shell, so it will get the stable octet electronic configuration. So sodium will become sodium plus by losing one electron, and it will attain electronic configuration like 2, 8. Same way, go to the magnesium. Magnesium electronic configuration is 2, 8, 2. So there are two electrons in its outermost shell. If magnesium loses these two electrons, it will get stable octet electronic configuration. So that magnesium loses two electrons and becomes magnesium 2 plus cation, and with the electronic configuration 2, 8. Aluminium. Aluminium have electronic configuration 2, 8, 3. So there are 3 electrons in its valence shell. If it loses these 3 electrons, so it will get stable electronic configuration, so that aluminium loses 3 electrons and forms aluminium 3 plus cation, and with the electronic configuration 2, 8. So this is the way metal loses their electrons from their valence shell to attain octet electronic configuration and forms cations. Now take some examples as non-metals. Let's take the 17th group elements and the 16th group element and 115th group element. Phosphorus belongs to 15th group and its electronic configuration is 2, 8, 5. So in its valence shell there are 5 electrons in its valence shell. So it cannot lose 5 electrons, because losing of 5 electrons is difficult than gaining of 3 electrons. So the phosphorus will gain 3 electrons, so that it will get the stable octet electronic configuration. Now phosphorus what will do? With 2, 8, 5 electronic configuration, it gains 3 electrons, and so that it will form P3 minus anion. So with the electronic configuration 2, 8, 8. Next, take an example from the 16th group. So let's take the sulfur as example. So sulfur electronic configuration is 2, 8, 6. There are 6 electrons in its valence shell. So what happens? to get octet electronic configuration, instead of losing 6 electrons, it is gaining 2 electrons is easy, so that sulfur gains 2 more electrons and get octet electronic configuration. So what sulfur will do? With 286 electronic configuration, sulfur gains 2 electrons and forms S2 minus anion with 288 electronic configuration. Let's take one example from the 17th, that is chlorine. So chlorine valence electronic configuration is 287. So if chlorine gains one more electron, it will get octet electronic configuration. So what happens? Chlorine with 287 electronic configuration gains one more electron and forms chlorine minus Cl minus anion with electronic configuration 288. So that this is the way metals, by losing electrons they will form the cations, and the non-metals by gaining the electrons they will form the anions. Now these cations, anions, with the electrostatic force they will come together and an ionic bond is formed between them. So since it is formed because of between the ions, that's why this bond is called ionic bond, and the reason for the formation of bond is electrostatic force. That's why this bond is also called electrostatic bond. And also the valency, it is the main reason for getting the bond formation is valency, octet valency. So that's why it is also called electrovalent bond. So you can call this bond as ionic bond or electrostatic bond or electrovalent bond. So in the next class we are going to see what are the energy changes while forming the cation and anion when these two are combining. What are the energy changes we will go to see in the next class.